Right, I've been making more adjustments. I added another set of coils, which are connected here, and my choke is connected on the across the last coil section, which is this one. I've got a bad connection somewhere because I keep knocking somewhere and it keeps going off, but yeah, as you can see, we're using 450 milliamps on the input at 20 volts, as I was showing you before. 20 volts input pulsed on the time pulse circuit. So 450 milliamps into 5.8486 volts DC. So that's the load it's going into right now, and 122 milliamps output. That's getting pretty good, isn't it? Don't say better than before. I mean, I used to, if you remember, in the previous tests I was doing, we would get a pulse. We'd get, when I first loaded it down, it would peak at like 130, but it would drop rapidly, and everything would slow down, and basically it could grind to and hover around 90 or 100 milliamps. Well, we're doing a lot better than before now. I haven't even tweaked it yet, and I have had some issues with my balance on my rotors. I've been fiddling about with the rotors because damn thing was vibrating, because I got the rotors out of sync. Well, what it was, it all happened because something was vibrating on this side and it was driving me up the wall. It was just vibrating all the time. So I stuck some cotton wool behind there. You can see cotton wool. I'll get a light on it. So I stuck some cotton wool underneath there, and that stopped it rattling. It was just driving me up the wall. Yeah, so I just thought I'd do an update. Let's see, so you can see what was going on. I'm just going to do a bit more twiddling on here actually. The LEDs really helped me a lot, helped me get things balanced out. Oops, it's so touchy though. I need to put some low value trimmers in really. Right, so let's see. Right, so speed's dropping a little bit, 4,140, but that's okay. RPM is, I mean output current, it's dropped a bit, so I need to knock that back a bit. Lots of fiddling around. Just turn them so the LEDs go out, then it picks up speed and settles down again. Right. Right. We lost a bit of current, but it's picking up speed, so the current will come back. There you go. We've got some speed back up. It's a bit touchy setting it up, but it's a lot of fun. Yeah. So as you can see, the LEDs come back on again because when the speed picks up, the triac circuit. But I mean, it's basically a bit of give and take. Um, I've got to not be too greedy, because if you set the trim pot so it turns on earlier and you try to get more current, all you're doing is loading down the input, and if you load the input down you just draw more current on the input, which is a pointless waste of time. So it's all about minimizing drag. So yeah, I just thought I'd go live and show you that. But obviously input output current is dropping slowly because the voltage on the output up there, which you can't see it, I'm not going to go over there again, it's 7.25 volts right now. We're getting a bit of solar panel power going to the supercapacitors as well, so things are moving a bit faster than what they would normally. Yeah, I'm quite enthralled. I'll explain what I'm planning on doing with my chokes while I'm here. I was having some trouble getting some toroids. The original magnet rings that I used, these magnet rings, I ordered a load off eBay before, but I can't seem to find any right now, so I think it must be something to do with China being in lockdown. All the factories aren't manufacturing them, so there's a bit of a shortage of magnet rings. So what I've decided to do is get a whole bunch of steel washers, and I can stack up, they're called shim washers actually, and basically will simulate lamination. So I'm going to create my own transformer out of shim washers, and I'm going to experiment with that because it means I can stack them, I can make them as thick as I want to get the right inductance for this. So instead of using these things, I'm going to be winding the thing with this thing I made to wrap my wire around this thing. I can just thread it through my toroids, which will be made out of shim washers. I could use ordinary steel washers, it doesn't really matter, but the shim washers are better because they're more tunable, because they're very thin, about 1/2 millimeter thick. So I'm going to be experimenting with some new designed of delay chokes, and instead of having this big thing on the end, they can be there. You see, it doesn't really matter if the chokes are at this side of the triac circuit or at this end of the triac circuit, because if you think about it, this is in series with this lot here. It all works together. Anyway, so I've got some new transformers to wind, and it's going to take me a while. This is why I 3D printed these little things, and I can just wrap my wire around between the holes, the hooks, and thread it. And I made it longer because the original one I was using was very short, and because the shim washers stack is going to be a lot taller, I'll need a lot more wire, so I'm able to get a lot more wire on these things. I just thread the whole thing through, because it's got these long forks on the end, the wire won't fall off, which is the whole point really. I made 2 of them actually. I put 2 of them. That's stuck on the printer bed, I'll leave it for now. So anyway, yeah, just a little update on what's going on. As you can see, we are gaining output. It tends to cycle a bit. It's the way the triacs work, but when the LEDs all come on, that's usually when the output goes up. Let's see, if that LED on this side comes on, then the output should go up again. Like, pretty bright actually. Yeah, anyway, just an update, not much else to talk about. Just thought I'd give you an update on the thing. Yeah, it's going a lot quieter now. It was driving me batty early, it was just really noisy. I managed to get it quieting down a bit now. I thought, what the hell's going on? You have to stagger my rotors. I have to rotate them so they're staggered slightly, so the polarity is north south north south north south all the way along, but it's just that there's two modes. You can flip it all the way around 180 degrees and it'll be out of balance. Weird things these rotors are, but yeah. So anyway, now it's balanced again, so that's good. It was just vibrating like crazy earlier and it was rattling things and yeah. I'll just tweak this one a bit more, I think. That other LED's not on it. If the waveform's not balanced properly, so the phase is a little bit funny. I can't get it to come on. There we go. Right, anyway, it's going to be probably a week before I get a chance to wind before I get the shims things, because I've got to 3D print some core plastic sleeves to go inside to hold the shims all together, the steel shims, which will form a toroid from iron core. Then I've got to wind the coils, and I've got to basically do a test wind, put so many turns on. I've got to do some calibrations to find out what the inductance will be. For example, I'd have to wind 100 turns on, say, 10 washers, or 15 or 25, and find out what in milli-henries I get, in order to get some basic idea on the kind of milli-henries I'll get based on the amount of washers I've put together. So I've got to get some kind of baseline to be able to work out how many washers I actually need and how much wire I need. It's a lot of fatting about. It's not that easy really, because I don't want to wind a whole bunch of these things and find out they're all wrong, do I? So I've got to play around with one to get an idea. So I'll probably put 25 of these washers, and I'll put so many wire, because I've ordered 100, so I want 4 stacks of coil really. So I would say 25 per stack. Yeah, I've just knocked something again. Yeah, I've got a loose connection on my socket. Anyway, that's it for now.